Okay, students. Now we are going to discuss a very important topic related to this chapter, that is the calculating a magnetic flux density on axial line of any bar magnet, or you can say that due to the magnetic dipole. So as you know, the magnetic dipole means a one magnet have a two pole, that is called north pole, and this point is called south. You know that the pole is the strength of the magnet, where all the strength are going to be accumulated, and every magnet have the two pole. That's why it is called dipole. And what is the meaning of axial line? See, the meaning of axial line means one line passing exact from the bar magnet, center of the bar magnet, that is parallel to this of the bar magnet. One line is going to be passed inside the bar magnet that is parallel to the bar magnet, that is called axial line. Okay, now what we have to do there is, suppose if you are taking any unit north pole, what you are taking? Unit north pole means you are taking at this point P north pole. What you are taking? North pole. And what is the strength of that pole? Is 1. Magnitude of that pole is 1. Now we have to know what is the magnetic flux density due to this dipole at P. Okay, as we know, the magnetic flux density is a P. So we have to know what is the net magnetic flux at point P due to this dipole. So on point P, what is the pole? That is a north pole. Okay. Now this north pole, what happened? Feel repulsion force due to this north pole. And what is the direction of repulsion? This one is the direction of repulsion. Okay. So the magnetic density due to this north pole on this north pole is B1. Okay. And what is the direction of this one? NP. The direction along with NP toward. Now come to this south pole. Due to this south pole on the north pole, because it is the north pole, so attraction it will come. And what is the direction? Is the direction of PS. Direction is PS, along the PS, because it is on axial line. So, and the value of magnetic flux density is B2. Because of that, it is a dipole. So B1 and B2, the magnitude wise same, but direction wise it is the opposite. So if you want to calculate net magnetic flux density, then B net equal to B1 minus B2. Okay, B1 minus B2. If you are able to calculate this value, you will easily get the magnetic flux density due to this dipole at point P. That point is where? It is on the axial line. Now how to calculate? Just to understand. First we have to know what is the magnetic flux density due to that this north pole at point P along the direction of NP. So very easy, as per the Coulomb's law, mu 0 by 4 pi. Okay, and because the magnitude of this one is a 1, so we are not going to calculate, and this one have the small m, pole strength. So m divided by, suppose from the center of the pole and the point P, distance is d, and the length of any bar magnet always the 2L. So from the point center to north pole is a L. In that case, the length of north pole to the point P is what? From here to here, what is the value? D minus L. Understand what I am saying? I am saying if this length from the point P to the center of any magnetic dipole is a D. Okay. And the total length of any bar magnet or magnetic dipole is 2L. So from the center to north pole is a L. So L plus L become a 2L. So this one is the L. So if I know the length of this, if I know the length of hole from center to the point P, then I can easily calculate from the point P to N, that is D minus L. Understand? So as per the Coulomb's law, mu 0 by 4 pi m by D minus L whole square along NP. Along NP it will work. Direction is along the NP. Now come to the B2 due to the south pole. It will become mu 0 by 4 pi m, and this value is 1, so we are not going to write 1. And here if the length is this length from here to the center D, so here if we want to know the length of this to this, so D plus L. This one is the D and this one length is L, so I added. So D plus L whole square, right? This one along what? PS. Because of the attraction force, we are taking that along the PS. Now come to the point. Now we are going to calculate magnetic flux V net total. What the value will come? We will put the simply value of B1 and B2. B1 is mu 0 by 4 pi m by D minus L whole square minus mu 0 by 4 pi m by D plus L whole square. Right? We are going to put the value. Now simple calculation is there. Okay, I will go with the calculation. So I am rubbing this. I am going with the calculation. Calculation of this. What exactly going to be here? So simple calculation is there. Mu 0 by 4 pi. It will be a common. And m also common, because here and here m is the same pole strength. So that is also common. Now here what we come? D square plus L square. I am breaking to this. Plus 2dl. Okay? 2dl. At the same time minus. I will break to this because we are taking the LCM. So d square minus L square, and because of this minus become a plus, minus minus plus, 2dl, bracket close, divided by d square minus L square, sorry, d minus L whole square into d plus L whole square. So d square, L square, d square, L square. What is the result will come? Mu 0 by 4 pi, 4, 2 and 2, 4. This one is the m and dl. We can write? We can write or not? We can write here, right? Now, this one I am writing d square minus L square into whole square. May question come ki ye kaise, how it came? Very simple. D minus L into D plus L as a whole square. We can do that. And A minus B into A plus B. What is that? D square minus L square as a whole square. So same thing we are going to do here. Understand what I am saying? This one understand? Okay. Now, so this one is that our one result is there. Let think that this L is very very small as compared to this D. L is very small as compared to the D. So let D is very very bigger than the L. So what we will think? L become a 0 or neglect the L. If you are neglecting the L, then what the result will come? Try to understand that. The result will come B net, magnetic flux density, B net equal to mu 0 by 4 pi, okay, and just we have to arrange this one. What we are doing? I am doing m 2L into 2D I can write by L I am neglecting. Just a second. Don't use this concept now. Don't use this concept. What we are doing that? What exactly we have to do? First we have to arrange mu 0 by 4 pi 2m m2l into 2d. You can write that. We can write like that, na? To this one. 2 2s are 4 and we just arranged. And here d square minus l square whole square. What the meaning of this one? What the meaning of this one? This one is the magnetic moment, and that is equal to the mu 0 by 4 pi capital M 2d divided by d square minus l square whole square. Now think that d is very bigger than this L. In that case, if d is L, then L equal to 0 we can count. In that case, what is the new result? B net, magnetic flux on point P due to this north and due to this south pole is what that? L become a 0. So new result will come mu 0 by 4 pi and here capital M 2md divided by, if L is 0, then d 2 2s are 4, d to the power 4. This d and this d is a cancel. The new result will come mu 0 by 4 pi 2m by d to the power cube. This one is the B net, where on axial line. On axial line due to this magnetic dipole. So you can calculate or you can use this formula if any pole or any charges over the axial point by using this formula. B is the net. B net is talking about magnetic flux density on axial line at P. The formula is B net mu 0 by 4 pi 2m d cube whole cube. That is our result for this magnetic flux density on axial line of magnetic dipole. If any problem will come to understand this video, go through again with this video. If again the problem will come, you can text me or you can go to the comments box and type where you are feeling the problem, where you are facing the problem. I will work on that. I will try to explain again this video on your message box. Thank you. Thank you, dear.